In question, they have discussed about the a particle is performing one-dimensional motion. A particle, what is meant by one-dimensional motion? A particle is said to perform one-dimensional motion if it moves along a particular axis. It is not moving along a y-axis, along a x-y axis. Okay, its motion is along restricted to a particular one axis. Then we say that the particle is said to be in the one-dimensional motion. So, a particle performing one dimensional motion has an instantaneous speed v, okay, and its value ranges between 0 to v naught. For your kind information, you should be familiar with the fact that the magnitude of instantaneous velocity is always equals to instantaneous speed. Indirectly, in the question, they have given the magnitude of instantaneous velocity. Since we know the instantaneous velocity is also a vector quantity, as it is a vector quantity, it possesses both magnitude as well as direction. In the question, they have discussed about the magnitude, but they have not discussed anything about direction. So we can assume that the particle performing one-dimensional motion can perform its motion along any particular direction. That is, either it can perform in right direction or it can also perform its motion in left direction. So, first, let us try to understand. If the particle is moving in the right direction, then the maximum velocity it can, with the maximum instantaneous velocity it can move is v naught. So, in this case, the maximum velocity becomes v naught. And if the particle is moving in the left direction, the maximum velocity it can reach in the left direction is also v naught. But since it is in left direction, I have to consider it as minus v naught. So when I talk about overall motion, then the maximum velocity achieved by this particle can be v naught and the minimum velocity achieved by this particle can be minus v naught. And with this, we can also say that the displacement in time t, always the displacement in time t is given by velocity into time. Okay, velocity into time. So here the displacement in time t is in the maximum displacement in time t can be v naught into t, and the minimum displacement in time t can be minus v naught into t. Why maximum displacement in time t? Because v naught is a maximum velocity. Then maximum velocity into t gives maximum displacement. Minus v naught is minimum velocity. Then minimum velocity into time t gives minimum displacement. So option B is true because the displacement always ranges between minus v naught t to v naught into t. Coming to option A, why the option A is wrong, let us try to understand. They say option A says that the displacement is always takes the non-negative values. That means that the displacement always takes up the positive values, but it's not true. So let us assume a particle can, if the particle is moving with the instantaneous velocity v for a particular time interval t, then in this case the displacement will be vt. But there is also a possibility that the same particle is moving with the instantaneous speed v, since it is like in left direction, so it will be minus v for a particular time interval t. Then in this case, I would say that the displacement of the particle will be minus vt. So here we can observe that the displacement takes up both positive values and also sometimes negative values. So option A is wrong. So let us try to understand why the option C is wrong. Coming to option C says that the acceleration also takes up always positive values. That is not negative values, that is nothing but positive values. Let us check this fact. Okay. Let us suppose that particle is at origin and it is at rest. Okay, and it starts moving in the rightward direction, that is in positive direction, and its velocity increases from 0 to v. Then in this case, the instantaneous velocity v, since in this case the acceleration I can find is v final minus v initial by t. This whole process is happening in the time interval t. Then the acceleration over the time interval t I can find is by v final minus v initial by t. Here the v final is v minus 0 by t. So I can get that the acceleration is positive. Okay, I am satisfied. But there is also a possibility that if the particle at origin, when it is at rest, it can start moving towards the left direction with instantaneous velocity minus v, and it is traveling with in the time interval t. Then in this case, my acceleration will be v final minus v initial by t, and here the v final is minus v. Then minus v minus 0 by t, it is negative value. Since the acceleration can also take up both positive and negative values, so option C is also wrong. So let us try to understand the option D. What the option D says? Option D says that the motion has no turning points. So in order to understand the option D, first you should be familiar with what the turning points is. So turning points are the particular position or the point where the particle changes its direction of motion. So since the velocity ranges between minus v naught to v naught overall motion of this particle, then there is a possibility that the particle having instantaneous velocity v can also switches to minus v. Then if this possibility is becomes true, then in this case there will be a particular instant where the particle has changed its direction of motion, that is from v to minus v. So if this scenario is possible, then we say that there is a turning point is possible for this overall motion of a particle.